some questions of the panelists as well. So Chris, if you wouldn't mind, please take it away.
Thanks so much, Sean. Thanks for the invitation to be here. It's a real pleasure. Just let me load up.
Sure, go ahead.
Presentation. Am I online now, or did I pick the wrong screen?
No, you got it. Go ahead and just hit your slideshow and you're good to go.
Fantastic. So I'm going to tell you a little bit about a couple of research projects that are going on at Carleton University. Full disclosure, I'm a cell biologist by training. My role is Director of Industry and Partnership Services within the Central Research Office. And so if I butcher the technology, that's on me and not on the great work that's going on within our university. And so the first project that I want to highlight is artificial intelligence-enabled satellite communication networks, led by Professor Halim Yanikomeroglu, as well as Dr. Gunesh Kurt, who joined Carleton as an adjunct research professor about a year and a half ago, and has recently accepted a faculty role at École Polytechnique in Montreal. There's also considerable contributions in this project by three very talented postdocs, Mohamed Abdelsalek, Aziz Chaudhry, and JD Mibiamo. Essentially, this project takes the lens that the next generation of satellite networks are expected to have a very high-speed inter-satellite link, or the connection in between those satellites. And if you believe that to be true, for efficient operation, this network, or any network using these different satellite networks, will have to have some level of autonomy, intelligence, resilience, self-organizing, and self-control as much as possible to not only reduce the cost, but also reduce the risk of human intervention in these very highly complicated settings. And so some of those important features, if you can think about what important features such a network would have to be, would be things like distributed decision-making, fault recovery, resilience, scalability. So can we add in subsequent satellites to these networks? And so this project will rely on artificial intelligence techniques at all levels, including the ground operations themselves, the onboard operations, as well as inter-satellite communications. Just briefly, I'll take a step back and tell you a little bit about Carleton University. We're a relatively young Canadian university, about 80 years old. We have 32,000 students, of which about 5,000 are graduate students. We're quite unique, despite a long history, and I think at the time was the first engineering program in mechanical and aerospace engineering. Currently, we're the only school in Canada with a Bachelor's of Engineering in Communications Engineering. You may know that there is a world ranking for telecom engineering, formerly known as the Shanghai rankings. Last year, Carleton ranked 27th in the world in terms of telecom engineering. We're quite proud of these stats. So very quickly, just getting back to this first research project. There's three components. The first one is outlined here and really talks about the handover management within the satellite network. Okay, and so due to the fast mobility of low Earth satellites, ground users need to be able to switch between the satellites frequently to keep that connection going within the satellite network. And the process of switching between those satellites is called the handover process, okay? And every time you do one of these processes, there's associated possibilities for error, whether that is signaling overhead or a processing delay, or even, we hope not, but certainly the risk is there for data packet loss, okay? In this stream, we look at jointly optimizing the resource allocation and the handover management process in these future satellite networks. The next piece of this project looks at the data packet routing, okay? And this is the process of relaying and forwarding a data packet. It originated from a source to a certain destination. And as you can imagine, in satellite networks, the source and destination points are distant terrestrial endpoints or users located several hundreds or maybe even several thousands of kilometers away from each other. And so in the future network of low Earth orbit constellations, we've got to come up with an efficient routing strategy to ensure that multiple satellites relay data packets autonomously between their far apart terrestrial endpoints. Okay, and inherent to this is how do we distribute those satellites within this? If you think of the globe as we all know it, certainly there are areas of that globe where we don't have any communications going on. There's not much communication going on in the middle of the Pacific Ocean, for instance, or the middle of the Siberian forest. And so how do we deal with an ununiformly distributed series of users and map that onto the satellite needs? The last stream of this really interesting project looks at the laser intersatellite links within those satellite networks. This project is moving incredibly well. I think to date, there's been a dozen publications that have been produced in a very short time. You'll see a fair bit of this work summarized or presented at the upcoming workshop led by IEEE or sponsored by IEEE called Satellite Mega Constellations in the 6G Era. And if you want some more information, there's an email contact here, Halim at sce.carleton.ca, and I'll put the link in the chat as soon as I'm done speaking. The next project that I'd like to highlight takes a different approach to solving some of the challenges with space communications, and that it's looking at silicon photonics as a means to improve wave antennas and their use with optical phase arrays. Okay. And so optical antennas are fundamental elements of to interface light between integrated photonic circuits, optical fibers, or free space ports. Within that, then, diffraction efficiency, reflection, broadband operation, robustness to fabrication errors, and compact footprint are all important parameters for optical off-chip coupling. The reality that everyone working in this or is trying to solve is that state-of-the-art Intel elements that are currently existing all report a trade-off between size and performance. This project will explore how to overcome this limitation to demonstrate the design of ultra-compact, efficient broadband, silicon antenna elements for off-chip emission using sub-wavelength grading metamaterial engineering. This project is a collaboration between NRC and Carleton University, and interestingly started with a very, very small amount of funding from the new Beginning Ideation Program. It's got a very significant component of training. To date, there is 2 graduate students and a postdoctoral fellow involved in this collaboration. Right now, the project's at the prefabrication stage, and we're looking forward to getting into fabrication over the next couple of months. Again, this project has been incredibly successful to date, and in less than 12 months has already generated 2 provisional US patent applications, as well as 2 peer-reviewed publications. So that's really all I wanted to highlight. Obviously, there's a fair bit more going on at Carleton in terms of space, not only in terms of research, but also in terms of teaching. But I'll end there and gladly hand things over to Jayshri.
That's great. Thanks a lot for that, Chris. Jayshri, you're on deck for a little presentation of what's going on at Western University. Thanks for that, Chris. And if you're just joining us, I saw a few people come into the room while Chris was talking. Go ahead and save some questions. We'll have some questions at the end. You can put some questions in the chat feature as well, and we'll get to those. Jayshri, take it away.
All right. Can you see my slides?
I can.
Okay. All right. Good morning and to everyone. And sorry, good afternoon. I've been here. Hold on. All right, thank you, Sean and SATCAN for this invitation to be here. It's my pleasure to talk about the space research and training activities at Western. And this is an exciting time for space exploration and related areas, as Chris just mentioned, including for new space opportunities. So first, a little bit about myself. I wear a couple of hats in my presentation today. So one, I'm a professor of electrical engineering, and I work on photonic instrumentation building. And this is for both satellite as well as for lunar rover and Mars rover instrumentation. And my other hat, which I'll spend more time today, is I'm also the Associate Director of Training for the Institute for Earth and Space Exploration at Western University in London, Ontario. And what I will do is I'll give an overview of some of the activities very briefly of our institute. Our institute was launched officially in 2019. It involves over 60 faculty members from over 9 faculties and 20 departments. Previously, it was a center for several years, and it got promoted from a center to an institute by the university, which reflects the current growth and importance of the space sector and also the interdisciplinary nature of this venture. And so the university has invested into creating this institute and moving forward with it. So what are the goals for this institute? There are sort of 2 main visions and goals. One is to launch Western into space. It seems very sort of bold statement there. But what that really implies is we're working to develop and fly Western-led space missions through high-altitude balloon projects, instrumentation development, and also small satellite CubeSat projects. And I'll be talking about them more. The other aspect, which is also important for the Institute, is bringing space down to Earth. And what that really means is you can have exploration, space exploration-based projects, but also what we're looking for is, for example, data in Earth observation data, or using some of that technology and techniques that are developed to explore remote and dangerous locations on Earth itself. So both launch Western into space, but also bring some of that development back down to, for Earth-based applications. So we broadly have these 6 research themes: Earth observation, monitoring and protection, exploration technologies, planetary processes and materials, galactic and stellar processes. We have a very strong astronomy department. We're going into space health and also space policy and law, which is also becoming very important nowadays. And so let me just go over some of the few projects that we are currently involved in. And this is just a few examples of some of the projects. There are also a few more that I don't have time to mention today. Happy to talk about them. The first one here is the Western University's Nunavut Arctic College CubeSat project. I'm a PI on this project. We have several co-Is. And this is actually one of 15 teams that is funded through the CSA's Canadian CubeSat project. And McMaster, and I can see will mention, is also one of those 15 teams. So here we are partnering with Nunavut Arctic College, and we are also partnering with our industry partners, Canadensis and MDA. So Canadensis actually provides us a 360-degree VR imaging camera, as you can see in that figure over here. The other, and this CubeSat is to be launched from the ISS at the later part of next year. The other thing I wanted to point out is our name. It's UPIC-1. It refers to a snowy owl in Inuktitut. And what we did is we had a naming competition in Nunavut Arctic College, and they came up with the name, which as part of this competition. And you know, it means snowy owl, which very much feeds into our payload, which is a 360-degree VR camera on either side of the CubeSat. The other things that are there, the Institute is also partnered with the Milo Institute in the US. This is a nonprofit institute that is out of the Arizona State University and funded also by Lockheed. And we have formed a partnership with them, and then we will provide a payload for a 6U project that's actually being built by the University of Texas, El Paso through the Milo Institute. So we're very excited about this. As part of this project, we actually have a couple of research components that we will actually include in that one new payload. So a couple of things about CubeSats. Shifting gear, I think everybody has in their mind the Perseverance rover. So there are 2 things here I wanted to highlight. One is the training aspect. So One of the things we're very proud of and happy about is our alumnus Raymond Francis, who is currently an engineer at NASA and involved in the operations team for Perseverance. And he's also a graduate of Western through particular, and I'll talk about this later, through our collaborative specialization program. And so, and this interdisciplinary program where he learned about both planetary science as well as the engineering aspects, has served him well today. The other part of this project that I want to talk about is actually the mass cam that you see at the top here. It has a multispectral camera. And one of the things that we are currently doing at Western is we've got funded by the CSA for an integrated vision system. This is a project that's led by Dr. Gordon Osinski, and I'm a co-I on this for the multispectral imager. And we're partnering with MDA, and this is funded by the CSA. And here what we're doing is we are building a multispectral imager similar to what you see there, but we are extending the range of this multispectral imager and combining it with the multispectral LiDAR that MDA is building for an integrated vision system. And this would be for a lunar rover for the exploration of the lunar surface. Other projects there, I think it was quite a bit that was talked about previously about photonics for satellite applications. One of the other things to keep in mind is you're talking about bringing space down to Earth. In Earth observation, we can kind of think of three main topics. One is agriculture, one is climate change, one is energy. And Earth observation is very important for what's called precision agriculture, which I'm involved in as part of building these multispectral cameras. Climate change, there are other aspects of it. This is not particular to Western, I'm just giving you an overview of what's there. And of course, photonics and energy is well understood. And this is just another example of some of the work we're doing. This is currently for terrestrial applications, but this is an example of a multispectral camera that we've built. We've tested on drones, and we're currently building one for the rover, and we're also building one for satellite operations. But this gives you an example of the kind of data product that comes up from these multispectral cameras that we can apply to several applications such as agriculture. And this one actually links up with what was talked before. Western and we're involved in the photonic integrated circuits for optical communication satellite links. We have a MITAX funded project with Honeywell Aerospace, and we are actually working with, as was mentioned, with Uni E at Carleton. We're also working with other PIs at University of Toronto and York University to build optical phased arrays for photonics and satellite communication. So this is a very interesting project that we've been working on for about a year and a half, and this actually allows us to use photonic integrated circuits for space applications. So it kind of brings in both my expertise in this project. Other things in here, we have new initiatives that we're looking at. The Institute is looking to space resources. We've got a small funding from the university to look into space resources. So this is such that asteroid mining, looking at the law implications, the policy implications. So this is something we're going to be doing this summer. Space health is another very big area. Space health has two things to talk about. One is health for astronauts who would be going, for example, to the moon relatively soon, but also to look at how to use some of those technologies for taking care of health in remote areas. So two aspects to it. And the third one I think I've talked about is Earth observation. And here there's also a push, besides getting technology up into space, how do we use all that data to actually give us meaningful information and impact on Earth? So these are some of the projects that the Institute faculty members are involved with. And just finally, a small piece on training. This is an example of what we call an analog mission. And here at Western, so part of the training is we get to have instruments somewhere up in the Utah desert, and a small group of students will be there handling the instrument, while then we'll have another group of students actually at the mission control, and they simulate a remote operation of an instrument. So we've had a couple of these type of scenarios, and we have incorporated this as part of the training program. So we have three training opportunities at Western. One is a collaborative specialization, and this is one of the Canada's only graduate program in planetary science and exploration. So it's a very interdisciplinary program, which has several graduate students anywhere from earth science, astronomy, electrical engineering, and geography, and we're expanding into health and law to give that overall rounded education. We also have a professional master's program we are starting soon, potentially in fall of 22, where we would have the opportunity for people who are working to actually get a professional master's program, with 8 courses, which they can take part-time or potentially full-time in the future, which will give them the entire scope from some engineering side, some science side, policy, and space mission details. So if you want to know more, I will put a website in the chat later on, and you can take a look at that. And finally, we have summer internship programs for undergraduate students, where we take a group of undergraduate students and run them through both a research project as well as a group project. And so we've done group projects on the CubeSat, on lunar science, and this year we will do something on healthcare and potentially asteroids, asteroid resources and hazards. And this is an example of the analog mission. This is in our operations room where the students actually participate. So this is anywhere from undergraduate to graduate students participate in these analog missions. And over here is an example of the high altitude balloon flight that we had a team at Western do and bring it back down to Earth. Okay, I think that's a very quick overview of the different activities. So I'll leave it open to questions at the end of the panel, and I will put some of these email addresses in the and locations in the chat box shortly. And thank you. And with that, I will hand it over to Steve to talk about activities there.
Thank you, Jayshri. That was awesome. Love seeing all these people doing all this awesome stuff out there. That was great. Love to see the pictures too. Steve Hranilovic, it's all up to you and McMaster, my friend. Take it away.
All right. Well, thank you very much, Jayshri. Thank you very much. That's wonderful. Just down the road, and I see that we have a lot of overlap. So I'm going to introduce myself first. I'm Steve Hranilovic. I'll be putting links into the chat as I give my brief comments. I really hope that we can have a discussion afterwards about some of the interesting directions and kind of the focus at McMaster. So McMaster Engineering is part of a relatively large university. We have about 7,000 undergraduate students, about 1,100 or so graduate students, about 210 faculty or so. So by Canadian standards, I guess we're about a medium-sized engineering faculty. Nonetheless, our university ranks as the most research intensive in Canada. And in the top, I think we're 14th in the world for global impact, and in the top 70 universities worldwide, as ranked by Times Higher Ed. So our faculty in particular has a number of interesting initiatives. I'm a professor in the Department of Electrical and Computer Engineering, but I also serve as the Associate Dean Academic. So my other responsibilities are to have overview of those 7,000 undergraduate students and of their programs. Now, in my brief comments today, I'm going to talk a little bit about research. I am a researcher in space optical systems, specifically in space communication systems. But I do want to talk a little bit about our clubs and teams and about our pedagogical approach at McMaster and learning through curricular and co-curricular activities. So I'll talk a lot about them and about how that leads to some of our industry collaborations or industry linkages. So starting off with the Optical Satcom Consortium. So it's been mentioned a couple of times. I've thrown its link into the chat because I think it's important. You'll see the Optical Satcom Consortium binds a number of leading industrial players in aerospace with a number of academic partners as well. Our role in this project really is on the development of novel technologies to enable optical satellite communications from space to ground or inter-satellite links, which will enable and benefit Canadian industry and Canadians as a whole, right? And so Jayshri mentioned a little bit of this. Canada, with its vast geography, is in dire need of broadband content distribution. And we have these unique challenges that broadband satellite communication links are uniquely poised to solve. And indeed, optical broadband satellite communication technologies are poised to excel at. So at the link below, I won't go into all in detail on the research objectives. I'll just give you a high level overview. We have colleagues that are developing new receiver technologies, new detectors, and sources at longer wavelengths. So again, longer wavelengths in the 3 to 5 micron range have beneficial properties in terms of propagation and scattering through the atmosphere. So as well as benefits to because they're not commercially available. So building sensitive detectors in that wavelength range is difficult. Building efficient sources in that wavelength range is additionally difficult. Combined with that is an algorithmic approach. So when we talk about detectors at the receiver side, there's a lot of communication theoretic and information theoretic work that's done in parallel with that to understand how to process the data out. The project that I'm leading in particular works on mitigation of atmospheric fluctuations due to satellite downlinks. Now, these satellite links, especially in LEO constellations, a high-speed downlink is perturbed by scintillation. A common way of seeing this is if you look across a piece of hot pavement in the summer, you'll see the shimmering or the twinkling of stars at night. In fact, when emissions are sent from a satellite down to Earth, they twinkle because of the atmospheric distortion. So how do we mitigate this atmospheric distortion? Now, astronomers have been looking at wavefront sensors and adaptive optical systems to do that at great costs. And in slightly a different scenario. Of course, stars aren't moving as fast as a LEO satellite across the sky. So our objective is not to take a beautiful picture of the LEO, but it is to track it, and it is to mitigate the sources of distortion in the atmosphere in order to improve communications efficiency. And it's an incredibly exciting multidisciplinary area. We have partners at NRC and at leading aerospace companies as well that have been fantastic in supporting us. We're interested also in developing optical beamforming for RF phased array. So with LEO constellations now, with intersatellite links, beamforming, radio beamforming is very important in order to have a number of narrow beams to service people with radio frequency, in this case, and downlink. And doing that with optical or integrated optical approaches is both an efficient and a cost-effective way of doing that in a robust way. And so that's been actually another key area of research for us. So I could go on. I love my research program. We have a large number of postdocs and graduate students working on that. And our research results are shared regularly through the consortium, as well as in published literature. What I'm most interested in, now I'm shifting hats from Steve, the researcher, to Steve, the associate dean. I'm really excited about our clubs and teams. And so I'm going to post a couple links there because I don't think I can do them justice. We have 3 main space-based teams. First is the NUDOS mission. As Jayshri mentioned, it's part of the Canadian CubeSat project. They started in about 2017, and the total mission timeline in orbit will be about a year. And the origin of this program, this project, is actually quite exciting. It started from a research project with a graduate student in our engineering physics department that built a system that can measure the ratio of both charged and neutral particles as they absorb in tissue or simulated tissue. And this is actually an important sensor to enable long duration space missions, even that is those that are beyond low Earth orbit. And so this project is one of the largest space-based projects that we have on campus. There are over 100 individuals involved in the project, mostly graduate students and undergraduate students. So undergraduate students make up the bulk. There's also a number of graduate students and a small number of postdocs and faculty members supervising them. The key feature here is that students are building all the boards, packaging. It's not only an integration project. For example, I know that they're building their own comm system, their comms board. The orbital computer is something that they've built and qualified themselves. And so this is actually super ambitious and part of our approach. So I should step back and say part of our approach in teaching at McMaster Engineering is really to be based on experiential learning and project-based learning. And that's where clubs and teams fit in. And I'll tell you a little bit about how this integrates with our curricular work in a second. The project, as Jayshri mentioned, is due to launch sometime in 2022. I know they've just passed CBR, so successfully with CSA, and so they're quite happy with that. They've qualified many components and participate in high altitude missions, and they are one of the most successful teams that we have on campus. So they're quite exciting, and not just engineers, which is kind of cool. They're business students, they're students in science, they're students from across campus, and that's again one of the great aspects of the project. We also have two smaller teams, the Mars rover team, which, you know, similar pictures to what Jayshri posted. You can see on their website, or that they're building rovers that can compete in the Ontario Rover Rally. Again, multidisciplinary teams spanning both science and engineering, as well as communication teams and students from the arts as well. We also have a rocketry team, which is relatively new. However, they've done a number of flight tests already. They've completed flight sensor modules. They're developing Class C and Class D rockets that they're launching, and starting tests on the solid propellant motors. How does this all integrate with our curriculum? So the teams are great, but how do students get credit for this? So one of the unique features that I think is very important is that students are given choice to select those clubs and teams, or those elements of study that meet their personal objectives. And what we're doing at MAC is we actually give course credit, technical course credit, for student participation in teams such as NUDOS or the rover team or the rocketry team, where they make significant technical contributions. So that's one of the really important parts. A lot of these students work on these teams, and yes, they do it out of a passion project, but they're also given course credit because we recognize that not all learning is going to happen in front of a professor, in a lecture hall or in a classroom. It can more often happen on these kind of multidisciplinary teams as well. Indeed, none of this would happen without close and active industry linkages. These student clubs are all supported by industrial teams, just as the SATCOM consortium is as well. But the research side is industrially motivated, but certainly our educational teams are also linked clearly with them. And I can tell you that the students from many of these clubs are snapped up immediately. Our graduates are snapped up immediately into the Canadian aerospace industry. And so this forms I think a really unique training environment for students, both in Canada and globally. So that's my pitch. Those are my brief comments. I'll turn it back over to Sean, and I look forward to any kind of questions or going into more depth on any of those aspects in the follow-up.
Steve Hranilovic, thank you very much. That was great. And if I could ask the rest of the panel, you can go ahead and turn your microphones and your cameras on, and we can chat a little bit. I have to say, after a long year, this is actually giving me a real lift. Like, it's awesome to see how many people are out there working on stuff. I mean, I'm not really in that game from the technical side. So knowing that all this stuff is going on, and these clubs and these people and young people especially getting into this, it's really giving me a lift, honestly. If you don't mind, Chris, I'll come over to you as the Director of Industry and Partnership Services. The reason I kind of wanted to bring this together is I was attending a Zoom thing some months ago, and it occurred to me that nobody really talks about the schools. All the flash and dash happens with SpaceX and the private companies and these kind of things. And meanwhile, there's so much going on at the schools. Talk about the partnership between industry and the schools, because obviously the schools are heavily involved.
Yeah, I think partnership with industry is more important in 2021 than it's ever been in the last 2 or 3 decades in Canadian research. I was in a similar panel a couple of days ago, and I said the two most popular terms in Canadian academia right now, or particularly Ontario academia, are intellectual property, followed very closely by partnership. Right, and it seems like everybody's chasing the partnership, and at first glance, it's really easy to dismiss this and say, well, this is just a cash ploy for universities to get more money in the door. The reality is, more and more universities are committed to finding solutions to problems that matter, that have a direct application. We're also recognizing our role in training a future generation of industrial or government or even nonprofit scientists and engineers. And so we need these real world problems, if you will, right at the beginning, right at day one of the first year of undergraduate curriculum, to ensure that we are not only meeting the needs of people that are ultimately funding these post-secondary institutions, but ultimately meeting the needs of our students that are coming to us for this, right? They're looking for that very rich training with not only just the theory, but also the practical component. And so, we and many others, it's the same case at Mac and at Waterloo, is Jayshri, I just messed that up, didn't I? I'm so sorry.
It's down the road.
I got a W. I'm so sorry, Jayshri. I knew as it was coming out, it was wrong. It's the same approach. It's how do we serve our industry partners better? And because we're all trying to create sustainable win-win partnerships.
I saw a lot of head nodding, so I'll just toss it over. Steve, do you want to address the partnership angle?
Yeah, so Chris is bang on in understanding that that learning is no longer out of context. So whereas fossils such as myself learned technical concepts out of a context. I just learned math and science, and design was something that was kind of done at the end. Now that's front loaded. So very much students are engaged by having a purpose or a context in which learning is done. And that learning is done to solve problems that matter, as you said, Chris. That's exactly right. So those can be technical ones. In space, those can be part of the UN Sustainable Development Goals, right? In which infrastructure and broadband content distribution fit. These are kind of widely based needs that are kind of influencing our entire planet. The thing I would add to Chris's piece is that multidisciplinarity is a key issue here. And by that, I don't just mean engineering and scientists. I mean, engineers like to think that as an electrical engineer, if I talk to a mechanical engineer, wow, I'm multidisciplinary. And really the big problems of the world today are going to be solved by teams of technologists. I mean, engineers and scientists combined with people in the humanities, combined with social scientists, combined with economists, maybe even an accountant, and wow, a finance person. I mean, these are all important skills. And so that's where these teams come in, these clubs and teams come in, as well as they're embedded in our curricula. So we have project-based courses in every level of our study, which link all of the engineering teams and allow students from other places as well to come in and solve real problems. So I think that's the key piece. Industry has a great linkage in our research, and the idea is to be relevant. We want to solve real problems that need to be solved. As well, industry in Canada has been actually quite flexible in understanding that we want to solve near-term problems, but also with an eye to the future. And I think that's actually a very wise approach to ensure that IP generated in Canada remains in Canada and is here to enable our aerospace industry into the future.
Jayshri, if you want to touch on that, also the interdisciplinary stuff, because you're doing so much training. Are you training people outside of engineering to be involved in stuff to do with space?
Absolutely. In fact, the collaborative specialization that I was talking about, that's the aim. So in there, we have students from electrical engineering. We all have students from earth sciences, from geography, and what am I missing? Astronomy. And we actually have these students work together on several of these projects. So some of those projects that you saw, the high altitude balloon, including the CubeSat project, at the grad level, this collaborative specialization gives them that interdisciplinary background. So I totally agree that going towards space, it's not just interdisciplinary between the different engineering disciplines, but engineering across to the other ones. The other two ones, which are also getting important now, and we are working towards is law. Because space law and policy is now going to become very important when we start talking about, can we go to the moon? Are we going to mine those resources? Well, how are we going to handle this? So a student also needs to know some of the law aspects to it. So we're actually working on that over this summer as well. The other part is the undergraduate. And undergraduate too, an interdisciplinary approach is required. So some of these research projects that we have over the summer, we usually have, and Steve knows this, is that we have undergraduate projects where we have an undergraduate student working with one faculty member. And that kind of training is probably not enough. So we actually have expanded that to have these team students working with each other. And in the teams, there are law students, there's going to be health students, science and engineering, of course. And how are they going to work together on a single project? So this is also the kind of training. So interdisciplinary training is important. I agree.
I just wanted to put up a poll really quick. It's only a few questions, so you'll see a poll pop up on your screen. If you'd answer a couple of those questions, it'll spur a little bit of conversation for us. Also, you don't be afraid, everybody out there, to put a question in the chat, and I'd love to ask it. Steve, I'd like to touch on those clubs, which I never even thought about. I always think about school back in my day, which was, I mean, there were clubs to play some cards or something, but school back in my day was you sign up for a course, you made sure it was on the day you wanted, you went and did the course, you got a credit and you walked. Now it sounds like there's much more extra, and Jayshri, what you were touching on as well, and Chris, Steve, extracurricular sounds like it's very important for the background of students in this area.
100%. I mean, and it's not called extracurricular, it's now called co-curricular. So
Okay.
It is a complement. I mean, it's recognizing that you don't just learn in a formal curricular component. You can actually learn a lot by doing external work, project work. We've revamped our entire undergraduate program to be project-based and challenge-based. So you're actually solving, you're training to be an engineer or a space scientist by actually practicing it in mentored projects throughout your study. So you learn concepts and you apply them immediately. Clubs and teams are just an example of that. And I think one of the great things that we've done in the recent times is recognizing that they deserve course credit, so official credit towards degree. So that is both a technical credit. We have two types. You have a technical credit you could get if you're doing meaningful technical work. Like if you're designing an onboard computer for a space-rated computer for a CubeSat, I think that is a legitimate and important technical contribution that should be recognized with a technical elective credit. But also on the complementary studies side of things. So if you're managing a team, if you happen to be managing or raising or an industry liaison person as a student that's raising funds or talking to others or organizing the team, that is a valuable complementary study. And so we have faculty that mentor both of those courses that require students to do reflections and rigorous academic components around those experiences, but nonetheless, they're centered in these experiences that they get. And the key point and the thing that students really respond to is they get to choose the experience. They get to do it on their own terms and when they feel it's most appropriate for them. And so that feeling of agency, I think, is a key feature. Now you're starting to get me passionate about the pedagogy, the educational side of things. I think it goes hand in hand, right? Because recognizing that universities are here, our society funds universities really to train and develop future talent, and that's really what our aim is. And so that informed, the societally informed education is core to what I think most Canadian institutions are doing, and certainly McMaster Engineering.
I'm just going to open, thank you for that, Steve. I'm just going to open up the results of that quick poll that we did here, see if there's any surprises in here. I'll throw it up. Jayshri, what do you think? I asked here, in the past, space has been promoted to you as a good career path, and the majority, admittedly small sample that have answered, but there is a majority there that have said false. Space has not been promoted to me as a good career path. Jayshri, what do you think?
I think that it is picked up recently. So it is fair to say that maybe a few years back, it wasn't something that you considered as a career path. But I think that has changed considerably in the last few years. So today, there's this stats, I don't want to put stats out there, but I think Canada is among now one of the top new, if you look at new space companies and new space startups, we are among the top, I think, 3 in the world that are actually coming up with these startups. And I'm actually hearing of alumni of Western coming to me, hey, I've just started a startup here. You want to hear about my space startup? And I'm hearing that more in the last 2-3 years, whereas it is true maybe 5 or 6 years back I didn't hear, but now it's picking up very strongly, and Canada is a major player in that.
Chris, where are you on that? I noticed I just scrolled down. It says, I asked, you would entertain the idea of space as your future, but, and the vast majority is that they're already doing it. So those are the kind of people that are in this chat, but there are a few people who said they don't know how. So if somebody wants to get involved in quote unquote space just because it turns them on, how do you guide them towards that?
I think everyone on this panel is pretty geared towards the academic route to getting into space, and I think we all recognize that Certainly with many highly specialized fields, there is a reasonably high bar of minimum education that's required in order to get into that sector. So I would encourage anyone that is trying to consider it to look either at your current university or to consider this as part of your application for a subsequent degree program to look at what are those offerings. I think for me, and you know, I'll go back to my disclaimer at the beginning that I'm not an engineer in the space sector by any stretch of the imagination. But to me, what's really exciting about all of this work here is sort of the indirect spillover effects, and so you know the requirements for space exploration or space travel or space communication requires technology discovery in order to do so that has profound impacts on everything else, right? You know, the work that I was highlighting by Professor Yannico Maraglu has got profound implications for rural and northern Canadian connectivity. Right, the implications of that are profound, and so the point that I'm getting around to making is there are other back-end ways to get into space. Right, maybe you don't have the requisite training to be a rocket engineer. However, you've got a strong communications background. You can take that background and use it for applicability on space-based projects. So there's many different ways that that you can skin a cat, to use the old phrase, and I think that's equally well applies to space as well.
Steve, where are you on guiding people in their path? If they're, let's say they're just entering university now or something, and they're like, they have all these big ideas, and you're like, okay, this is probably the route you want to go, and that might have many paths, but what do you think?
Yeah, I mean, there's no one right way. I mean, I echo what Chris said, right? So I think engineering programs in particular in Canada are highly regulated. They're accredited. They have very little flexibility in terms of electives that they can take. And so adding these components, I think that's really what the appeal to these co-curricular activities are. It gives students some flexibility, but there are new programs. So there are bachelor, you know, at McMaster, we have Bachelor of Technology programs that are not engineering programs, but that are looking at the application of engineering technologies problems, including space systems. There's also collaborative degrees that combine arts and technology that are in development, that are now being offered both at Mac and elsewhere, that look at building graduates that you know, as Chris mentioned too, looking at the societal impacts, that appreciate the technology, but that understand the societal impacts, and that again feed into technology development. So really, I think it's about giving agency to the student, showing them that menu of options, and there are no better ambassadors than the students themselves. And so these peer groups are infectious, and so they're self-sustaining. We have no issue in attracting students. They attract. They're a self-sustaining society or self-sustaining group.
Jayshri, just a comment. It looks like someone's commented more or less along the lines of, it's not what you know, it's who you know a lot of the time. And what would your answer back to that be, or maybe how to get around that? Or is it just a case of going up and meeting people so you know more people?
I think it's also to identify where these programs are. So Steve talked about undergraduate. Even in the graduate program, there are many space-based professional master's program. A little plug there, we're going to have a professional master's program at Western in space studies. So if you are a working professional, but you want to look ahead, I think one of these programs is what you should address. If you're at the undergrad level, I totally agree. It's not just important to take your courses, you have to find these extracurricular activities. I think when I was a student, it was optional. Now it's almost required that you find an alternate to your courses to add to your program. The other thing is also summer interns. People maybe undervalue summer interns. I have actually talked to many students, and they recently had a talk by a former student at Western, and every summer he found a different place to go work on something very interesting. And I asked a question, so how did you manage to find this? And maybe that will answer some of the questions. He said, you just go after and apply for every one of these opportunities that you could, you know, that you're potentially interested in doing. In fact, in undergrad, it's a little easier. Even in the grad, you know, summer opportunities across in Canada, in the US, worldwide, I think you should keep the options open. And there's many exciting summer programs out there. So between summer programs, professional master's program, undergraduate students. There are many opportunities. That's how I got involved in space myself. So back in the 90s, I joined the Students for Exploration and Development of Space and started a student chapter, one of the co-founders at University of Michigan. And then over the next 6 years, we worked on a project that then went up in the space shuttle. So it's you have to put in the time and effort as a student and go beyond your courses. That's very important.
Yeah, it's interesting you raise that. I just from the marketing and the entertainment business that I've been in all my life, it's if it's not there, start it. You don't have, why if you're beating your head against the wall and applying and it's not going somewhere, then start something on your own. So that's what you're saying.
But can I add to that, Sean?
Yeah.
So what I would add too is that there's value to for industry to participate in these clubs and teams. So these clubs and teams are always looking for industrial input. Of course, financial support or in kind is always important. So a little plug for all of our clubs and teams. But I mean, what they're really looking for is mentorship from industry that is in practice. And so these are always open opportunities. So yes, we have a huge group of students that are desperately excited to do this work. They just need the context. We can provide them with the fundamentals, but this is a place where industry can partner with us and certainly help in training the aerospace workforce of the future.
Chris, further to that, what about people that might come to you and say, I don't want to get trapped? So if they end up in the academic stream, is that it forever? Or if they're in the industry and they want to go and teach people, so are these streams mutually exclusive, or what's the story?
Absolutely not, and I think it's even more so than it ever was before. But when I was defending my thesis, I was doing the sort of do I stick with what I know in academia or do I jump into biotech? And I went to one of my advisors and I said, look, I'm really struggling here. I've got a really solid offer to start up a great research program in a biotech company. It's academically and scientifically very sound. I'm really worried if I jump to the dark side, am I going to be blacklisted? And Keith was probably the most anti-industry advisor or mentor that I've ever had. And he said, you can do anything you want in your career for up to 2 years. Okay, and so go and take the leap and go if you think you want to explore something. Nowadays, people are moving back and forth between industry and academia like they never have before. And so, that's not an offer, a hiring offer, but there is some flexibility there. And if you've got an appetite for something and you want to go and try it out, then I think we're much more evolved and flexible in our ability to deal with that and less siloed than we were even 10 years ago.
I'll get your commentary on that too, Jayshri. Industry, academia, the two streams, they can cross, right?
Absolutely. I actually have students who are doing their PhD and they're also having a company on the side. They have a startup as well. And I think that, as you mentioned, there's lots of faculty members who have moved back and forth. The boundaries between academia and industry is not as hard as it used to be maybe before, and now it's even encouraged. Even in our graduate training, we're telling our students, okay, two sides. One, they're being asked to be part of more industry type research projects, so even the research that they come out with is not just purely academic, it's already involves the industry component. The other side is actually students actually come to us and say, okay, do you have a project that actually has an industry partner? Because that's the one I want to join. And automatically you can see the doors are now open between the two. It's not just academic only or industry only. So.
Steve, touch on that. I mean, okay, you need an industry partner. It'd be nice to have an industry partner. So go about, what is it, like cold calling around and introducing yourself to these industry people, or how does it work?
Yeah, so as an academic, that's always difficult. I mean, I think webinars like this are a great place to start. I think SATCAN has a great role to play there as well, and they've done great jobs in linking people and in bringing synergies in Canadian industry together. I know I've talked a lot about clubs and teams, but I can't leave this webinar without mentioning one more great place for students to learn, and that's in co-op and cooperative education in workplaces. both at the undergraduate and graduate levels. We have a graduate co-op program as well as an undergraduate co-op program. We're always looking for employers. The space-based opportunities in aerospace in general are taken up incredibly quickly. Students can work for 4, 8, 16 months, 12 months at a time, and get credit towards a co-op designation. This is another way that we think students have to learn. And to be honest with you, a lot of these co-op opportunities start a relationship between the university and an industrial partner, which can blossom into research partnerships or other IP and intellectual development opportunities into the future. It's all about getting the conversation started.
And hey, that's what it's all about. I love getting the conversation. This is an awesome panel, by the way. I love having you guys in the same room. Just a couple of minutes left. I wouldn't mind just going right to left on my screen anyway. Chris, we'll start with you. If you were to tell someone why space, or what's bright about Canadian space and why they should get involved, what do you think?
I think the timing is fantastic. I think we're starting to see after decades of not much investment into that, we're seeing the tide turning from a federal government perspective. We're seeing the expansion of training programs and research programs in universities with a renewed focus on space and related spillover industries. And as Jayshri mentioned, I think we're seeing more and more space-focused startups that are flourishing right now. It's one of the few sectors that seem to be attracting early stage or venture capital investment right now. And so I can't see a better time than right now to jump into this game.
Excellent. Jayshri?
So I agree with Chris and what he said. I think the key point is that there are many more players coming into the commercial space industry now, which also means many more opportunities. And I think including the fact that many governments around the world are also coming up with space agencies. So there's a worldwide concerted effort to pushing forward space exploration and space-related industries. Keep in mind also what I would say is, it is not just, okay, I want to be part of this company that builds a rocket to go to space or a satellite that goes to space. There are many other related industries, such as Earth observation. You have a company that's actually working on the satellite data for different applications such as climate change. That is also part of sort of a spill-off or related to the space industry, and it's also a very exciting area. So it's not just, oh, I'm interested in putting something in space. No, there's many related industries, including remote area operations, that you want to consider. And all of this is growing. So
excellent.
It's a
And
very exciting time.
thank you. And Steve, we'll throw it to you. Why space?
So I think I echo my two co-panelists, but I would say that space holds the key to solving a lot of issues that are plaguing humankind these days. So Jayshri mentioned climate change, information exchange. We see in the pandemic, as we connect over Zoom here, the democratization of digital connectivity and e-commerce is an essential feature, not just in Canada, in Canada's north, in Canada's vast geography, but globally. So I think space is a key technology, a key area to solve the grand challenges facing humanity. And that's why it's an important thing to study.
Excellent. Jayshri Sabarinathan, Steve Hranilovic, and Chris Lannon. That was an excellent panel. Thank you very much for joining us. Hopefully we can do it again and catch up perhaps after the next school year starts, and we'll see what's going on with you three and with your schools. Everyone, thanks for joining us, and check out satellitecanada.org. And I'll also be posting this video to our YouTube channel. And panelists, I'll send the clip to you as well if you want to post it anywhere. So I really appreciate your time, and have a great day.
A real pleasure. Thanks, everyone.
Thank you.
Bye-bye.
Thank you.
Yeah.
Bye.